Good morning and welcome to the AVB Networking Conference. Glad you could make it. Our agenda for the day is pretty busy, as you see. We've got a lot of good content, guest speakers, presentations ranging the gambit of various applications for AVB. So I'd ask if you have any questions. There may be some brief times at the end of each of the segments, but please hold your questions until then. My name is Minich. I'm the president of LabX Technologies, and I'm the lucky guy who gets to go first. I guess I drew short straw. So let's jump in. AVB and WIFFM. So I'm assuming you've heard of AVB in some sense, otherwise you wouldn't be here. Audio video bridging. What's this other thing? WIIFM. This is the question that you're going to be asking yourself throughout this entire presentation. Not just mine, but each and every one of them. What's in it for me? Hopefully you're not asking where the door is, okay? So, who has one of these? Okay, great. So you're going to see throughout this presentation, I'm sort of an audience participation guy. It keeps you from falling asleep. I'm not that good of a presenter otherwise. Okay? So, everybody has a cell phone, right? Who has one of these? Now, don't worry, I'm not going to ask you to hold your wallets up because you don't trust those shady-looking characters around you any more than I do. So, now you're asking, all right, Lee, this isn't WIIFM, this is WTF. What are you talking about? So the point of this is that when you have an AV system, your AV system, and something goes wrong with it, you get the call. And your reputation is on the line. And you're the face that your client or customer sees with that. So when there's a problem, it causes pain for you, and we want to minimize that pain. Now, the flip side of that is, when you've got an AV system that's easier to install, easier to maintain, easier to expand, that gives you more opportunities with your customers. And that maximizes pleasure. And in the business world, we call that profit. And who doesn't want some more of that? So, let's talk a little bit about the world before AVB. Before AVB, we'll have to ask, why do we do AV networking at all? What are the benefits of Ethernet networking? And we'll go through a real brief history of some proprietary networking. And that'll get us to the core of this, which is an overview of the AVB technology. Again, why does AVB exist? What's the AVB terminology? If you're talking about a new terminology, a new technology, you need to be able to talk about the terms and know what's going on. And what do these AVB standards do for you? It's something I like to call, what do you do when the network is your ally and not your enemy? So, classic audio and video distribution. We all know, we all love it. It's a love-hate relationship, right? Single channel per cable. It's unidirectional. If you want to transmit and send, 2 cables. It's point to point. So I can go from here to only one other point. And it's time consuming to terminate. So we all know this. Looking at networked AV distribution, there are several benefits. First of all, I can get many channels on a single cable. I can get multiple types of media on a single cable, and it's bidirectional, all on one single cable. And it's one to many. Splits are free. We like free, right? And it's fast to terminate. A lot faster than solder and XLRs, and certainly when you start talking about the number of connections we've got in a single termination. So Why Ethernet? Ethernet, networking is done on Ethernet, period. We get to take advantage of the vast, vast economy of scale of IT infrastructure. And it's everywhere. Ethernet is everywhere. And like its father, Bob Metcalfe, said, never bet against Ethernet. Not even here on Vegas. And again, we've already talked about ease of installation. It's fast, it's easy, and it's convenient. So, real quick, real-time networking. So there's networking, and then there's the stuff that's real-time. It's typically uncompressed. We need to do that for low latency and other considerations. Talking about latency, deterministic latency is absolutely critical. You need to know exactly when it's going to arrive so you can do your job, which is dealing with time alignment and other acoustical things. And contrary to what Netflix would like you to believe, excessive buffering isn't acceptable in this type of environment. It's just simply not acceptable to see Mick Jagger belt out a line and then 2 seconds later hear it, right? I can't get no. Nope, no. And that is the one and only time I will ventriloquistically sing. You're welcome, you're welcome. So, let's take the brief history here. CobraNet. Who here has used CobraNet? I'm with you. First to market. Made its debut in 1994 from Peak Audio, which was later sold to Cirrus Logic Semiconductor. It had that concept of bundles. Put multiple channels into a single packet. It was heterogeneous data tolerant. And by that I mean you could have CobraNet data and you could have some other traffic. But notice, as I'm sure all of you know, that tolerant is in quotes. We'll get to that. And still to date, it has the largest number of nodes deployed, partially because it's been around for almost 20 years. So, let's talk about those bundles. What happens if I don't want to get 8 channels to that point? I only want 1, or 2, or 3, or 4, or 60. Too bad. You'll notice I got an asterisk there. So I use that to point out when I've got a pro on one slide, but yet it's still kind of a con in this next slide. So bundles, okay, it's also a challenge. 5.25 milliseconds of latency. Not bad in certain applications, but it did make it tough for certain other applications, especially if you had multiple hops. So live sound, sometimes in-ear monitoring, very demanding latency applications, a problem. You had to configure those pesky transmitter and receiver bundles. And it was heterogeneous data tolerant, but how tolerant, right? So if it was on a lightly loaded network, okay, not a problem, but it had no concept of other types of traffic. And so when you started to load it down, what did you have to do? You had to set up VLANs, switch configurations, right? Okay, the phone call, because somebody didn't set up the VLAN right, or somebody changed the VLAN on you. And it didn't have a migration path beyond 100 megabits. Migration paths and futures are sort of a problem with proprietary networks. So then a few years later, something called EtherSound came from a company in France called Digigram. Took a different tack, 64 by 64 channels, single granularity. How many people here have ever used EtherSound? Okay, slightly fewer. It's not as prevalent in the installation world, but it still had a footprint. Had much lower latency, and it could be daisy chained. So let's talk about that daisy chaining. Another one of those blessing and curse things. It was only for EtherSound packets. It was completely intolerant to other types of data. You couldn't get it through. I'm sure there's some joke there about French tolerance of non-French things, but single channel granularity. So 64 by 64 channels, but it was intimately tied to how much you could get down a 100 megabit stream. It didn't have a future either. And again, heterogeneous data intolerance, simply you couldn't get other types of data, and we always have other types of data to try to get down those pipes. Because it was broadcast, shot those packets all over the place, which made it very unfriendly for switches. And if you wanted to do bidirectional ether sound, you couldn't go through a switch at all. All right, so obviously there were some challenges there. So fast forward a few more years, and yet another pile of proprietary protocols come out. We've got Dante from Audinate, we've got QLAN from QSC, we've got Ravenna from the Lavo guys of ALC Networks. And they all kind of do the same thing. They use timing that was borrowed from VoIP. They use quality of service mechanisms, also borrowed from VoIP. They had the luxury that 1 gigabit networks were already pretty prevalent, so they weren't going to go down the same route of EtherSound and CobraNet and not be able to take advantage of those bigger pipes. So most of the times you'll see them on 1 gig networks. So QoS. One of the issues with quality of service is that it requires manual configuration of the switch, okay? And I don't know about you, but whenever there's humans involved, especially if it's not you, there's a tendency for something to go wrong. Prioritization, which is what quality service is not a guarantee. You can think of it as a really strong recommendation. A really strong recommendation that, hey, my data is more important than your data. But when it hits that first switch, guess what? Those switches can change the priorities. So Jim, you thought your conversation was really important? Well, I knew it come from Jim, so I said, let's put it down priority. So what it requires is highly engineered systems. Highly engineered systems. Think lots of care and feeding. Think careful policing and configuration of those systems. Because it doesn't guarantee things. It just makes recommendations. It doesn't lock down and guarantee bandwidth. It only makes priorities. You have to over-provision your network. So what's it mean to over-provision? It's a fancy word for putting more in there than you need. It's safety margin. So the better you want to sleep at night, the higher you want to over-provision that, right? If you like to sleep a lot, 25%. If you really like to sleep a lot, maybe 50%. And again, each one of these guys, you've got single technology providers from different companies, different single companies. And they're not interoperable with each other, right? 3 different things, they don't talk to each other. Heck, Ravenna, the name for Ravenna comes from the city in Italy where Dante's buried. I don't think that's interoperability. So, let's talk about why AVB exists, right? So there's a bunch of really smart people in the IEEE, the Institute for Electronics and Electrical Engineers. Do they just like writing standards? Some of them do. I've met those guys. It's scary. But a lot of them work for companies that like to make money, and they said they saw that there were needs, that the network as it existed didn't meet it. Legacy Ethernet, the way it existed, simply wasn't made to deliver AV traffic. When Bob Metcalf and friends got that data to go from point to point, they were happy just to make sure that it showed up on the other end. They had no concept. They couldn't fathom the thought that you would want to be doing real-time, sensitive, prioritized AV distribution over that system. So the guys at the IEEE said, hey, don't work around the network, fix the network. This is really important, okay? Don't work around the network, fix it. Come on, all right. Audience participation, what do we say? Don't work around the network, fix it. Thank you. I'm glad somebody participated. I'll give you the $10 later. The other thing is that proprietary solutions are never, ever broadly adopted. And the silicon companies, those guys are into making things that sell in the millions, all right? So they saw this as an opportunity to add functionality that could be used in a large, large number of applications. And us Pro AV guys, we get the benefit of it. So let's talk about terminology. A talker is a device which provides AV media onto the network. A really good example of that in the audio world would be a microphone. Now, a listener, as you may guess, is a device which receives data off of the network. Another good example of that in the audio world would be a powered line array. Now, just because we've got talkers and listeners, there is a V in AVB, so that means a talker could be a video camera, and a listener could be a display. And there are devices that are simultaneously talkers and listeners. Consoles, DSP matrices, all kinds of equipment. An endpoint is a generic term for when we're talking about devices in general, talkers, listeners, or devices that are both. A stream is a flow of AV media from a talker to a listener. Here's a very, very important point. AVB is really efficient at also delivering to multiple listeners. Okay? So how many applications do you have where you have a single source and you need to get it to 20, 30 amplifiers? Happens all the time, right? And AVB, from the ground up, very, very efficiently does that. So, there's a term. The B in AVB is a bridge. What the rest of us in wired Ethernet typically call a switch. It is an active participant in the AV media conversation. And what I mean by that is it's media aware. It knows every packet, on a packet-by-packet basis that goes through there, that this is important AV media. So it treats it differently. And that makes AVB your biggest ally in networked AV. This is a very, very crucial, fundamental change from pre-AVB technologies to now. AVB has a term called a cloud now. It's not cloud computing, those wonderfully overused terms. This is IEEE speak for an AVB network. And the AVB network consists of endpoints and bridges. And within the cloud, non-AVB devices are outside of that cloud. So by definition, a non-AVB device, maybe a control computer, maybe some legacy CobraNet device or something like that, that can make it through here, but doesn't get the same level of quality or all of these guarantees, is outside that. And being outside that, the network actively polices it.